A mysterious visitor has been spotted in our solar system. Astronomers have detected an object from another star system, designated 3I/Atlas. What could it be? An ordinary comet, or perhaps a controlled spacecraft from an extraterrestrial civilization? This intriguing possibility has been suggested by a well-known astrophysicist, Avi Loeb. The big question remains: will this enigmatic object encounter our planet Earth? Let's dive into the details. Astrophysicists have identified characteristics in this extrasolar object that hint it might be a controlled spacecraft. Every time a foreign interstellar object enters our solar system, and this is the third one we've detected, Avi Loeb presents the findings like a gripping detective novel. On July 1, 2025, the third interstellar object was officially recorded. We've already discussed this object before. It's known as 3I Atlas. So, what makes this third object so unusual? First, it was fortunately discovered quite far from the Sun, near Jupiter's orbit, even a bit farther out. This is rare. Comets typically don't reveal themselves so far from the Sun because it's cold there, and they don't evaporate. However, if this is indeed a comet, and let's emphasize, because Loeb claims it isn't, most astronomers currently lean toward the comet theory. If it is a comet, it must be large since telescopes can detect it, meaning its body is substantial enough to reflect sunlight and be visible. Second, the strange tail that has appeared on this comet might not be a tail at all. Loeb and his English colleagues pointed this out in a published paper. It could be a random photographic effect, or simply an elongated image caused by the object's motion smearing its appearance in photos. What is the size of this object? We don't know for sure. If it's not a comet, it's a fairly large body, reflecting a significant amount of sunlight, possibly around 20 kilometers in diameter. But if it is a comet and has warmed enough to start evaporating, it surrounds itself with a gaseous cloud, a temporary atmosphere we call a coma. This effectively increases its apparent size, while the solid core might be smaller, around 1 to 2 kilometers. This remains unclear since the object is still far away. What other peculiarities caught the attention of the American English Research Group? Let's list them. First, the orbital plane. The direction of this celestial body's entry almost exactly matches the plane in which planets move within our solar system. All planets orbit roughly in the same plane, known as the ecliptic. The orbit of this incoming body, which we'll call Atlas, lies almost within this plane. It gives the impression that this object intends to encounter planets in our solar system, with an inclination of nearly 5 degrees. The probability is low, though I'd argue it's around 5 to 6%, not less than 1% as Loeb and his colleagues suggest. Still, it's a small chance that it came in at such a shallow angle, like a stone skimming the water's surface. The second peculiarity is its direction of travel. It entered moving opposite to the rotation of all solar system planets. From the North Pole, planets and the Sun rotate counterclockwise, but this object came in clockwise, flying head-on into the planet's motion. How strange is this? Here I disagree with Loeb, who claims the probability is less than 1%. In reality, it's exactly 50-50, either clockwise or counterclockwise, depending on the approach parameter. This isn't particularly noteworthy, yet they consider it improbable. Combined with its near-ecliptic motion, however, it does become a low-probability event. Many are familiar with Comet Swift-Tuttle, which approaches Earth only once every 133 years. Yet few realize we witness its tail's debris every year. The Perseids form from dust particles left behind by Comet Swift-Tuttle. This year, the meteor shower peaks on the night of August 12-13, with visibility lasting through late August. So, head to a location with minimal light pollution and enjoy the celestial display. Now, back to the object's trajectory. I'm directly quoting the astrophysicists. A close flyby past 3 planets awaits this object. Within the next 2 to 2.5 months, August, September, and October, this rapidly moving body, traveling at 60 kilometers per second, will pass very close to Mars. It recently passed near Jupiter, quite closely though not impacting, and will come exceptionally near Mars. Satellites orbiting Mars will capture images, despite their limited optics, during this close encounter. Then, if it so desires, and here's the crucial if this body isn't natural but a controlled alien spacecraft, it could perform a maneuver. Flying past Jupiter and Mars, it might execute a gravitational slingshot, using planetary gravity to alter its trajectory, potentially enabling a flyby of Venus. 3 close approaches are unlikely events. Why would it need to pass Venus? After such a maneuver, it could approach the Sun. We're familiar with such techniques. The Parker Solar Probe, for instance, uses Venus flybys to slow down and dive closer to the Sun, studying its inner corona. So, these maneuvers aren't exclusive to extraterrestrial visitors. We've mastered them too. If everything unfolds as speculated, this visitor might not exit the solar system like Oumuamua and Comet Borisov, but could remain within it. Gravitational maneuvers can accelerate, redirect, or decelerate a craft, depending on the flight path and chosen direction. Why would it aim for a solar orbit? Moving within the ecliptic plane, this cosmic visitor could potentially encounter Earth. Here, we enter true science fiction territory. The scientific paper openly references concepts like Leo Szixen's dark forest and the Fermi Paradox. If this is an artificial object, and that's a big if, manipulating these scientific facts and assuming it's not natural, one could theorize planned gravitational maneuvers leading to an Earth rendezvous. Incidentally, if it's a natural object, we're out of luck. It won't approach Earth closely, passing too far for detailed study. It will travel near the Sun when Earth is on the opposite side, with solar glare hindering observation. But if an Earth encounter is intended, we might witness it around late November or early December this year. Intriguingly, Loeb and colleagues describe their work as educational, demonstrating computational astronomy's potential to model an artificial object's motion. It's a valuable exercise that could also be correct, a viable tactic for an interstellar visitor. We have mere days, perhaps weeks, until observation results are processed and published, clarifying whether it's a comet or an artificial object. If it's a comet, we'll see a tail and coma, indicating unguided flight. I'll add a speculative note. If it's artificial, it might mimic a comet, enveloping itself in a gaseous coma and emitting a tail. We're familiar with military deception tactics like smoke screens. Thus, we must scrutinize whether it's a genuine comet or a cosmic visitor disguised as one. Object 3I/Atlas isn't the first where Loeb suspects artificial extraterrestrial origin. Each of the 3 interstellar objects entering our solar system in recent years has unusual traits. Let's recap. In 2017, scientists first recorded an interstellar object within our solar system. Confidence in its extrasolar origin stems from its speed. While the Sun is massive, it can't retain objects moving too fast. Local objects move at moderate speeds, but an interstellar visitor can enter at tens to hundreds of kilometers per second, ensuring it speeds through and departs. Such an object arrived in 2017, Oumuamua, a name quickly memorized by astronomy enthusiasts. Oumuamua, the first interstellar object, held many mysteries. Its origin was unclear, and it was the first of its kind, puzzling astronomers who detected none before. Additionally, as it departed, it seemed to activate a propulsion system, slightly accelerating. Loeb noted all this. He's a respected Harvard astrophysicist, but Oumuamua's odd properties captivated him, leading him to frame it as an enigma, a great motivator for scientific inquiry. Unfortunately, we discovered Oumuamua late. It approached from the sun's direction, and astronomers avoid pointing telescopes sunward due to blinding glare. We spotted it only after it passed Earth and was exiting the solar system, leaving no chance for pursuit or extended study. Still, we learned key details. It had an unusual shape, hundreds of meters long but only tens of meters thick, resembling a cigar-shaped spacecraft as depicted in sci-fi films. Secondly, it defied Newtonian laws. After passing the sun, it gained extra speed. While solar gravity should have slowed it, it seemed to engage thrusters. Yet no exhaust plume was visible, unlike comets ejecting gases. 5 million asteroids in our solar system are cigar-shaped. Loeb proposed it might be artificial, a spacecraft or space debris from another system. Personally, I suspect it wasn't debris. Its trajectory seemed premeditated, skimming inside Mercury's orbit to harness solar energy, as Loeb highlighted. Just 2 years later, in 2019, the first interstellar comet was recorded, Comet Borisov, a pride of the Sternberg Astronomical Institute, discovered by our colleague Gennady Borisov. Designated 2I, it was the second interstellar object. Then, after a 6-year gap, on July 1, 2025, the third interstellar object, 3I Atlas, was registered. Fascinated by Oumuamua's artificiality, Loeb investigated further, theorizing such objects arrived earlier undetected. This is plausible. We don't yet monitor the entire sky, only now improving with robotic telescopes. Of the 3 interstellar objects, 2 were found by robots, the third by Borisov using a homemade telescope, somewhat embarrassing for professional astronomy. Loeb examined Meteor patrol data, networks of cameras continuously recording meteors. If multiple cameras capture a meteor, its 3D trajectory can be calculated, determining its origin and impact site. Among numerous records, Loeb found one meteor track with exceptionally high speed, indicative of interstellar origin since solar system objects don't travel that fast. Extending this, if such objects regularly entered Earth's atmosphere, why not search for their remnants? Most burn up, but larger ones might survive impact. The tracked meteor led Loeb to hypothesize its debris fell in the Indian Ocean. He secured funding, chartered a vessel, and used magnetic dredging to search for metallic meteorite remnants. Meteorites are often magnetic. Iron-rich ones contain 5–6% iron, and if it were a spacecraft, metals would be present. Loeb discovered tiny metallic spherules on the ocean floor. Droplets formed from surface ablation as the object heated, traversing the atmosphere. Their composition is peculiar, according to Loeb, who argues it's rare, suggesting not just extraterrestrial but extrasolar origin, possibly from alien spacecraft material. Not all meteorite experts agree, some attributing it to known iron meteorite varieties. Nonetheless, Loeb's initiative has spurred interest in hunting interstellar objects. In the coming years, astronomers will monitor the entire sky, ensuring no intriguing object goes unnoticed. If you've enjoyed this cosmic journey, make sure to subscribe, like, and share this video so we can continue exploring the universe together.